Hello, today we're going to look at plotting straight line graphs again, but this time using something called the gradient and intercept method. And again, this should be a review for you. So starting off with looking at the line that has equation y equals 2x add 3. So that is already on the graph over here in purple. And if we wanted to work out what the y coordinate was when x is 0, we can substitute 0 in for x here, and 2 lots of 0 add 3 is just 3. So that means that we know the point 0, 3 is lying on this line, and you can see that over here it's going through the point 0, 3, so the point 3 on the y-axis. And that point is called the y-intercept, and you can see that here. And also, whenever x is 0, you're going to lose this part of your equation. That value is always going to be 0 there. So at that point, y is always just going to be equal to this constant at the end. So whenever we look at a straight line graph, we know this constant at the end is where it will cross the y-axis. Okay, so moving on, if we had to plot this equation from scratch, we've already done the first bit, 2 times 0 add 3, and when x is 1, we'd have 2 times 1 add 3, and that would give us 5. So the next point would be 1, 5. And when x is 2, we'd have 2 times 2 add 3, which would be 7. So we know it's going through 2, 7. The other thing we know is if we think about our work on sequences, as we discussed last lesson, the fact we've got a 2x here, just like if we had a 2n as the nth term of a sequence, we would know that that sequence was going up in 2s. And that's exactly what you can see is happening here. This is a sequence that's going up in 2s. So I can actually fill in the rest of the table by saying, well, the next one will be 3, 9. And then after that, it's going to have to be 4, 11. So for every increase of 1 in x, y is going to increase by 2, and we can see that because the coefficient of x here is 2. So what does that look like on the graph? If I start with x is 2 here, and we know y is 7 from our table, if I increase x by 1, then y is going to go up by 2, and my next point will be here at 3, 9. So that is called the gradient of the line. And for every 1 along, we go up 2 in this case, because we've got 2 lots of x. So this is the key bit of information, and when I've talked through this, you will want to pause the video and copy this down. In general, a straight line equation takes this form, y equals mx plus c. And what you need to know is that m, the number in front of x, the coefficient of x, is the gradient, and it tells you how many you go up for every 1 along. So how many you go up on the y-axis for every 1 along the x-axis. And the constant, the plus c part, that is the y-intercept, and it tells you where the line crosses the y-axis. So pause the video at this point and make sure you've got that copied down into your books. Okay, moving on just to have a look at another example. This was the example we just looked at, y equals 2x add 3. We know it goes through 3 on the y-axis, just here, and we know for every 1 along we go up 2. So a long 1, up 2, a long 1, up 2. What happens though when the gradient is negative? So in this case, we've got y equals negative 2x add 9. Well, first of all, we know that the intercept is 9. So we know it's going to go through 9 on the y-axis. And the gradient here is negative 2. So that means for every 1 along, we go down by 2. So you can see here going through 9 on the y-axis, and then every 1 along down by 2. 1 along, down by 2. So in general, if you've got a positive number in front of x, your graph will slope this way. And if you've got a negative number in front of x, your graph will slope this way. Okay, so we're going to go through a few examples now. So I suggest you sketch down some axes and then pause the video and see if you can work out what this graph should look like using the gradient and intercept method. Don't draw out a table and substitute values for x. See if you can do it using the gradient and intercept method. Okay, so we know that the intercept here is +1, so we should be plotting a point on the y-axis at 1, just here. And then we know that the gradient is 3. So for every 1 along, we're going up 1, 2, 3. So our next point will be there, and then 1 along, 1, 2, 3. Next point is there, etc. And we plot a few points and then join them up, and that's what our straight line should look like. Don't forget to join your points up at the end. Okay, here's another example. You can do this on the same set of axes, so pause the video and see if you can plot this using the gradient and intercept method. Okay, so what we can see here is that the intercept is +6, so we're going to plot a point at 6 on the y-axis, and then the gradient is 4. So for every 1 along, we're going to go up along 1, up 1, 2, 3, 4. So the next point is right there, and we can plot some other points. We can even go backwards. We've got to remember then that we're going to be 4 down, and again, and then join those up, and we should get a nice straight line. Here's another one for you. Pause the video and give this one a go. Okay, so the intercept here is -3, so we're going to plot a point at -3, and the gradient is 5. So a long 1, up 1, 2, 3, 4, 5, and again, and then we can join those up to make a nice straight line. Okay, slightly more challenging this time because we've got a gradient of 1/2. Now that's going to mean that for every 1 along, you go up by 1/2. So pause the video, again on the same set of axes, see if you can plot this using the gradient and intercept method. Okay, so the intercept is at +2, so we're going to plot a point at +2 on the y-axis. And then for every 1 along, we're going to go up by 1/2. Now, that's a bit tricky to plot then, so it might be easier to get it accurately done if you think, well, in that case, I'm going to need to go along 2 to go up 1. So that is perhaps the easier way because then we're going through nice integer coordinates. And then join those up, and that's my straight line. Okay, here's another one for you. Again, you can do this on the same grid. This time though, we've got a negative gradient. So see if you can pause the video and plot this using the gradient and intercept method. Okay, so the intercept is at +12 right here. And this time the gradient is -3. So that means for every 1 along, we're going to go down 1, 2, 3. And then again, along 1, down 1, 2, 3, and so on. Join them up, nice straight line. Another one with a negative gradient for you to practice. Pause the video and give this one a go. Okay, the y-intercept here is at 10, and then we're going to be going along 1, down 4, and again, and then we can join that up, get a nice straight line. Okay, a word of caution here. On the last examples, if I go back, you can see I've got the same scale on both axes. So just 1 square is 1 unit on the x and on the y-axis. But your gradient is not about the number of squares you go along. It's about the scales on the axes. It's about the units on the axes. So if I take this set of axes as an example, here I've got 4 squares representing 2, and I've got 5 squares representing 5. So when I think about going along 1 on the x-axis, it's not along 1 square, it's along 1 unit. So this is where 1 is sitting. So I'm going to need to go along 1, which will be 2 squares, and then up however many my gradient is telling me to. So for example, if I plot y equals 2x add 2, my intercept is at 2. Well, my y-axis is just 1 unit per square, so that is just going to be here. And then I'm going along 1, which will be 2 squares, and then up 2. So up 1, up 2. And that will be my next point. And then when I'm done, again, I can join them up. So just be really careful that you're not thinking in terms of squares. You're thinking along the terms of what you've got on your axes. Okay, this is your exercise for today. You can do this all on the one grid. Draw out a fresh grid. Don't use the same one that you had before. Follow the instructions for drawing the grid out. And you can draw them all in different colours if you want to. Make sure you label each graph with its equation so that when we mark these next lesson, you can remember which one is which. I suppose you could label them with just 1, 2, 3, 4, 5, 6, 7 and 8, but you're going to need to know which one is which when we mark. So pause the video at this point and have a go at plotting these graphs. Please use the gradient and intercept method and don't draw yourself out a grid.